Assalamualaikum and good evening all. So today we have a new topic on operational performance indicator. The learning outcomes for this topic are that at the end of this topic, the students should be able to understand the metrics or the indicator that have been used to measure the performance of the manufacturing. And the second one, the students should be able to determine the manufacturing performance related to quality, time, productivity, utilization, and efficiency. In this lecture, we are going to learn about quantitative performance indicator. So we are going to learn indicators that give you numbers. So these numbers are able to let us track and assess the performance of our operation in a certain period, okay, to evaluate the new technologies or the new system that we introduce, to identify problem and therefore what are the improvement that we need, to compare alternatives, and also to assist us in making decisions. So these are the performance indicator that we are going to cover. The first one is the yield and defect. The second one, productivity. The third one, equipment availability, and then resource utilization. And lastly, the manufacturing lead and cycle time. So the first indicator is yield and defect. By definition, yield is referred as the percentage of non-defective items of all produced items. Okay, so it shows you how effective or how correctly your operation is functioning. Okay, so the general formula is that yield equal to number of non-defective items over number of all manufactured items times 100%. Okay, however, when we when we assess the yield of our production, we have also detailed yield assessment. Okay, so this detailed yield assessment can be divided into further three categories, which is the first pass yield, the throughput yield, and the roll throughput. So first pass yield, or FPY, is the percentage of good products produced without considering the rework, or when the product passed through the process for the first time, right, according to the quality required. Okay, so they are not defective. Okay, so first pass yield by formula can be calculated as number of non-defective items for the first time, okay, they go through the process, over the number of manufactured items at that process times 100%. Okay, for example, when we have a process that produce in total of 100 products, and out of this 100, 40 products are defective. Okay, so 40 products are not working well. Okay, okay, so therefore we know that 60 products are good. Okay, 60 products are right. Okay, so first pass yield is equal to 60 over 100 times 100%, and this 60% is our first pass yield. Okay, so at this moment we do not consider yet whether we are going to rework or not the defective items. Okay, so the importance of first pass yield is that we are able to focus on how to make things right, because if we have to rework, this will cause additional costs, and also this shows that we have inefficiencies. Okay, if our first pass yield is too low. Okay, so let's say we have 3 processes in the system, and we want to know the final first pass yield for all the 3 processes. Then we have to time the percentage of first pass yield for each process. Okay, so let's say we have 3 processes with the FPY 60%, 80%, 90%. So the final yield you have to times all. Okay, 60 times 80% times 90%, then you will get 43%. Okay. Okay, so next is the throughput yield. So throughput yield is the calculation of yield when we consider also the rework products. Okay, so normally this would be equal or higher than first pass yield. Okay, so throughput yield, the formula is given by the number of non-defective items first time plus rework items over number of manufactured items times 100%. So let's say the process produced 100 products, and out of these 140 are defective, but after rework another 15 pass the quality requirement. Okay, so we know that during the first time 60 products are good, okay, because 40 minus 40 that are defective, and then after rework another 15 are good. Okay, so we need to consider this additional 15, and therefore our throughput yield, okay, sorry, there is mistake here, it should not be FPY, it should be TY. Yeah? Okay, so 60 plus 15 over 100 times 100%, then we will get 75%. So raw throughput yield, or RTY, is the throughput yield of multiple processes of a product, okay, which consider the rework. Okay, so multiplication of individual throughput yield of each process. So if there are 3 processes A, B, C, and the individual TY or individual throughput yield are 65, 85, and 95%, then you have to just multiply every percentage of the process to get the total RTY. Okay, so here you will get 52% as the RTY. Okay, the importance of calculation of RTY here, it shows us the probability that a unit of production or service will be produced correctly, okay, or at acceptable quality. And also when we compare RTY and FPY, we are able to identify which process has too much rework. Okay, so it shows some inefficiencies at the process, okay, that need to be improved. So the second indicator is the productivity. Okay, so productivity measurement is to indicate how productive is our operation. It is a measure that it is an index that measures our output. Output is the finished product, okay, whether finished good or services that have been delivered relative to the input. Okay, input are resources that used to produce the product. Okay, so input can be labor, material, energy, and so on, other resources. Okay, so productivity in short is the ratio of output over input, and it is important to determine how competitive our company is. Okay, so output can usually measured in 2 form of units. Okay, so the first unit, it could be that the output is measured in the quantity of items, okay, units of items, or it could also be that the output is measured in terms of monetary value, okay, how much sales are gained from the selling of the products. Okay, so the first productivity performance, we have 3 categories of productive performance that we can measure. Okay, so the first one is the partial productivity, which is also known as a single factor productivity. Okay, so the single factor productivity compares output to individual inputs. Okay, it is commonly used in evaluating operation. Okay, example, we are measuring the labor productivity, or we are measuring the machine productivity. So it is productivity of a single factor. Okay, capital productivity, energy productivity. So these are some of the formulas or method where we can use to measure the labor productivity. Okay, for example, if you want to measure the labor productivity, it will be the output units, okay, the number of your products, over the labor hours that have been used to produce that product. Okay, or machine's productivity. Okay, you can measure machine's productivity by finding the ratio of outputs over machine hours. Okay, or material productivity. Okay, output mass over raw material mass. Or capital productivity, output sales over capital value. Okay, the capital for equipment, total facility and inventory. So here are some other calculations that are also possible, okay, for labor productivity and others. Okay, so the first one we have already seen in the previous slide. Okay, unit of outputs per labor hour, but you can also calculate labor productivity based on unit of outputs. Okay, the quantity of your output products per shift. Okay, or the value added product, okay, the product that has passed the quality control over the labor hours, or the dollar value, meaning the monetary value of your products, okay, over the labor hour. Okay, so there are many ways that you can use or you can calculate and determine the labor productivity and machine productivity depending on which indicator that you want to know. Okay, here is one exercise related to the partial productivity just now, where the first question, determine the productivity for the cases. Okay, the first one, 4 workers install 720 square yards of carpeting in 8 hours. Okay, meaning per worker, meaning each worker take 8 hours. Okay, so what is the productivity of this situation? Okay, so the first one, you have to calculate the total area of the yards of carpet that has been installed, which is 720 square yards, over the 4 workers. Okay, so the 4 workers, they are working 8 hours per worker, so you have to multiply 4 by 8, you will get 32 hours. So the productivity for this, the labor productivity here is 720 over 32, which is 22.5 yards per hour. Okay, and then the second situation, a machine produced 70 pieces in 2 hours. Okay, however, 2 pieces were unusable. Okay, so you need to calculate. Remember, productivity is based on the finished items that meet the requirement, the quality requirement. So we need to consider only the usable piece. So the usable piece here is 68 over the 2 hours time. Okay, so you will get 34 pieces per hour for this machine productivity. Okay, next is a multi-factor productivity. Okay, multi-factor productivity compares output to combination of input. Okay, so it is not just one input resource that we are considering. Okay, we consider multiple resources. Okay, for example, it can be that we are considering the combination of labor and capital. Okay, the combination of labor, capital, energy and material. Okay, whichever the combination that we use, we must make sure that all the inputs have the same unit. Okay, in the denominator part. Okay, so example here, the formula, multi-factor productivity, which is calculated based on the output, okay, quantities of the finished product over labor, material and overhead cost. Okay, so all the resources in the denominator section there have all the same units. It is calculated in cost. Okay, labor cost, material cost, overhead cost. Okay, so they have all the inputs have the same units. Okay, and last one for the productivity is the calculation of total factor productivity. So basically, total factor productivity compares the total finished product, okay, the total good and service, with all the inputs used to produce them. Okay, so again, the unit should be the same for all inputs in the denominator part. Okay, but this time you determine all the inputs that are required in the system to produce these outputs. Okay, so the formula is simple: output unit of products over all inputs. Okay, so the inputs must have the same units. Okay, if you are usually to to make all the inputs have the same unit, we use the monetary value of that resources. So to let you understand more about these topics, I have exercise in the next slide for you to practice. So here is one exercise that related to the productivity. Please try yourself, okay, whereby I have all the answers in the next slide, but you have to try yourself and check whether you are able to get the answers as the solution given. So for conclusion on this topic, productivity, okay, productivity is a very important measurement, okay, for the individual department or organization, because you are able to track your performance over time and see whether improvement is needed. Okay, and then if we have two firms, okay, A and B, that have the same level of output product, okay, they produce the same amount of finished product. However, A require less resource, less input than B because of their higher productivity. We would say A is more competitive. Why? Okay, this is because A can charge customer with lower price, okay, due to the lower cost, or if they charge this product with the same price, A gain more profit. Okay, and therefore A would be more competitive in the market, in the industry. Factors that affect productivity, we have few factors that could affect the productivity level. Okay, just now we only learned the indicator, but we have to know there are many factors that affecting this indicator. Okay, it would be the processing method, the automation level, okay, the capital that have been invested, okay, quality of the final product, the amount of product that meet the quality requirement, okay, the technology used, okay, and also the management. Okay, so if we want to improve our productivity performance, we may have to look back what are the factors that affect this value in our formula for the productivity just now that we have used. The third one is equipment availability. Availability is defined as measure of reliability for the equipment. Okay, how reliable the equipment is. Okay, so the formula is given by availability, which is A equal to MTBF over MTBF plus MTTR, whereby MTBF is mean time between failures, okay, and MTTR is mean time to repair. Okay, so basically MTBF is the time that the machine functions well. Okay, so you need to digest this. Okay, because if you see from the diagram there, okay, MTTR here is the time where the repair of the equipment starts until the resume of normal operations. Okay, meaning at some point here the maintenance time stops. Okay, so when the maintenance time stops, the normal operation can begin. Okay, so the time when the normal operation begins until the next failure occur, it is called mean time between failures. Okay, so MTBF. Okay, so next we will learn on how do we calculate or how do we determine the MTTR and MTBF so that we are able to evaluate the availability just now. Okay, so like I said, MTTR is mean time to repair. It is also equal to maintenance time. Okay, it means the time when the clock starts, when the repair starts and ends, okay, when operations are restored, okay, when the normal operations can resume. Okay, so MTTR include the time to troubleshoot or diagnose the problem, the repairing time, okay, the testing period, the time to assemble and start up the asset. So meaning it is the maintenance time where the production time is not happening. Okay, so the formula for the MTTR is the total maintenance time divided by total number of repairs. So you have to calculate the total number of the total duration of maintenance time for a certain period that you want to evaluate, and divided by how many repairs that happen, okay, the frequency of the repairs. So this indicator is important to decide, okay, to make decision whether to replace the equipment or proceed repairing time from time, whether there is a need for training, okay, process change or process improvement, and also to do some adjustment in the production scheduling. Okay, let's say you want to evaluate the MTTR for a pump in 1 working day. Okay, so here given a situation, a pump that fails 3 times in a work day, okay, the first repair lasted for 40 minutes, while the other 2 repairs lasted only 10 minutes. In this case, MTTR is equal to, okay, the total time for the maintenance, okay, 40 plus 10 plus 10 divided by the number of repairs, which is 3 times, okay, because the pump failed 3 times and therefore the maintenance is executed 3 times. Okay, so the MTTR is 60 divided by 3, which is equal to 20 minutes. So the average time for repair on that pump is 20 minutes. Okay, so but for this calculation, you have to consider that each failure has a different severity level. Okay, while some require days to investigate and repair, others failure might take just minutes, okay, just a very short time to fix. Okay, but MTTR, they can only give you the average on how much repair time to expect for that equipment. Okay, but it doesn't tell you the different severity level. Okay, if you want to know how severe is is a certain failure, you need to go more in details on the individual maintenance time for each failure. So MTBF, okay, mean time between failure, it is also understood as how long equipment can stay running or operating for a given period between unplanned breakdown. Okay, so formula is given, MTBF is equal to total operating time divided by total number of failures. Okay, so it is the approach is similar to the previous slide on the MTTR, but this time we are considering the operating time. Okay, importance of the MTBF is that we can decide to issue investigation. Okay, if the MTBF is too low. Okay, schedule for predictive maintenance. Okay, and also estimation cost of breakdown, frequency of failure. We are able to do some financial planning, okay, based on this indicator. Now let's try to understand more about MTBF. Okay, based on the example previously on the pump, let's say the operation has expected run time of 10 hours. Okay, because of the pump failure, it lost 1 hour. Okay, due to the maintenance just now, and operation could run for 9 hours. Okay, so how do we calculate MTBF? So the total operating time, okay, when you exclude the maintenance time, in this case it is only 9 hours. Okay, and the number of failures, we know that it happened 3 times in a day, so 3 failures. So the MTBF is equal to 9 over 3, which is 3 hours. So the MTBF for this pump is 3 hours. Okay, we can say that the pump is in average failing every 3 hours. Okay. The fourth one is the resource utilization. So based on the resource utilization method, we are calculating the fraction of time that the workstation or the machine or the worker is busy over the long run in the process. Okay, is occupied with the process. Okay, so normally it is difficult to achieve 100% utilization. Okay, for example, in a job shop type of operation, is usually 65 to 95% resource utilization. Okay, it is very much occupied, very much utilized. Okay, um, but for the continuous process, it is almost 95%. Okay, so most of the time it is occupied. Okay, it is the resource is being utilized. Okay, so for the manufacturing operation, the resource utilization is calculated based on the formula of resource demand over resource availability. Okay, while for the service kind of operation, the resource utilization is calculated as demand rate over the service rate time number of servers. So let's say example on how these indicators work. Okay, so here I have example of the calculation for the manufacturing and service. Okay, let's see first for the manufacturing. We have a station for packing that receive 40 items per hour. Okay, the station has 2 robots. Okay, each robot can pack 30 items per hour. In this process, what is the utilization of robots? Okay, so based on the formula, we know that utilization is equal to resource demand. Here, the resource is demanded to complete 40 items per hour, and the resource available, meaning the capacity, which is 30 for each robot times 2 robots. Okay, so when we divide this, we get 67%. So let's say the company wants to improve. Okay, which number of packs would be required if the 2 robots should have a utilization of 85%? So you can just manipulate the formula and you are able to determine, or you are able to get that the number of packs that should go to this station is 51 packs. Okay, so that the robot have 0.85 or 85% target utilization, meaning the precedent station, okay, the station that before the packing need to be improved, so that the resource utilization can be improved in this station. For service, this is for a restaurant situation where we have a chef that is able to prepare 5 orders in an hour. However, the order arrival rate is 20 orders per hour. Calculate the utilization of chef in this process. So demand here is 20 because the order received 20, but the chef is only able to prepare 5, okay, and we only have 1 chef. So the utilization rate is 4, which is 400%. Therefore, there is no way that this chef is able to complete the task in the given time. Okay, because the utilization is more than 100. Okay, actually it is 4 times, okay, than the capability of the chef. The last indicators that we are going to see the last indicators are the manufacturing lead and cycle time. Okay, so for this one, we will learn about manufacturing cycle time. Okay, remember, manufacturing cycle time meaning the cycle time for the whole, for the entire manufacturing operation. So this is not the batch cycle time. Yeah, this is manufacturing cycle time. So it is defined as the total time taken to transform raw material into finished goods. Okay, final products. Okay, so you may also find that the manufacturing cycle time is also spoken as net production time or productive plus non-productive hours. Okay, so productive hours are equal to inspection plus processing. Okay, so these 2 activities are considered valuable activities, okay, that provide value for your final product. Okay, so inspection time is the time spent on activities related to quality control, and processing time is the time spent on the actual process. Okay, meanwhile, non-productive hours are the movement time. and also the queue time, and also another one is the setup time. Okay, so move time is the loading activities, unloading activities, or transporting activities in the facilities. Queue time is the waiting time, okay, before any manufacturing task can commence. Okay, and setup time is the time taken to set up the machines, and therefore materials could not be processed yet. Okay, so the importance of knowing manufacturing cycle time, you are able to know how efficient your production. Okay, you are able to have insight on your productivity, and also therefore uh, you can evaluate whether need improvement, okay, and to identify problem, okay, the profitability, competitiveness. And also for food, this manufacturing cycle time can also impact the shelf life of the food. Okay, you do not want to have certain perishable food have too long manufacturing cycle time on the production floor. Okay, otherwise it could affect their safety or their quality. Okay. Okay, the next one is manufacturing lead time. Okay, if the manufacturing cycle time concentrate on what happened during the production floor, during the material on the production floor, so manufacturing lead time is the total amount taken, time taken for completing, okay, the procurement process, okay, the procurement of raw material, the production process, and delivery to the customer, okay, until it reach the customer, okay, once the product is required. So lead time is defined as procurement of raw material plus storage plus manufacturing cycle time plus storage, okay, plus delivery to customers. Okay, so important is that it is the same as the manufacturing cycle time, okay, but manufacturing time is on the overall process, starting from your procurement of your raw material, okay, until the product reach your customers. So you are able to know more about your supply chain. Okay. So in conclusion, okay, we have discussed indicators, some indicators, okay, not all. Of course, there are other indicators to measure the performance, okay, related to time, quality, productivity, and efficiency. Of course, there are other metrics that are also important to measure the performance of operations, such as sustainability indicators, financial indicators, customer perception, acceptance, market, okay, flexibility, okay, robustness, okay, innovation, and so on. So measurement must be effective for analysis and monitoring the performance that you want to monitor. And for the purpose of evaluation, you must collect and measure the correct data, okay, according to your objective, okay, and therefore your strategy can be realized. So that is the end of lecture on operational performance. Thank you, class.